where is the technology right now as far as disaster recovery, backup, and ability to recover on HANA compared to, say, a typical BW system?
It's kind of interesting because most people that I work with, and I work on a few HANA projects right now, what they're doing is disaster recovery. It's easy. You size your dev box, so your QA box equal to your production box, and then you can replicate back from that in case it goes down. And the replication speed you'll have is between 5 and 20 gigabyte per hour. So it's basically on the memory space that you move over. The high availability components with multiple name servers and multiple, so you can build up to 3 name servers and then have index servers underneath. Most of these features, it does work and it's up and running, but Service Pack 5 comes out in a few weeks. And in SP5 is when you find the high availability. So disaster recovery is already available. It's the high availability will come in Service Pack 5. So it's pretty solid.
Yeah, it's also going to be really where you go with some of your hardware providers and what their capabilities are to back it up, some of the different points. The thing that you do need to remember with this is as much as you think this is purely in memory, and the analogy that I give all the time is you're writing a Microsoft Word document, your computer crashes, you haven't saved, you're cursing like a sailor because now you have to rebuild your document from scratch. That is not actually what happens in all this. There is a persistent storage behind it that you're not necessarily recognizing, and I don't know the chapter and verse on the book, but I know it's in there because I know I remember writing that part of it. But there are actually point-in-time backups, so you will lose an infinitesimal amount, if anything. So you have the ability, as everything stores and writes to it, there actually is a persistence layer to this. So this is not like purely it's in pure cache. It's not as much as we all say it's in memory, there actually is persistence behind this. Yeah. And I know it's in there, I don't remember exactly which chapter.
What you guys are saying then is that if the power goes out...
If the power goes out, you're not completely hosed.
There's a disk, they're typically 5 times more disk space than you have memory. So if you have a 1 terabyte memory system, you'll have 4 terabytes behind the scenes for the persistent files, and you have 1 terabyte for log files. It's kind of a nice rule of thumb. There are other ways of sizing it. We show you how to do sizing screenshot by screenshots. But yes, there is a persistent, and those disks are mirrored. So if one crashes, even the disk crashes, you have a secondary disk. And it's all bundled into the same appliance. When you acquire this one, you see some pictures. We actually show you pictures of the inside of the box and explain what's going on. Because there is a persistent area. There's some built-up redundancies inside the box.
And we do joke about it a little bit because that is one of the biggest questions and concerns that certainly I get. Yes. I'm sure you do too. What happens if it crashes? Do you have to rebuild, 6 billion rows from scratch? No, absolutely not. So it's something that we can joke about a little bit because it is absolutely not an issue.
So the redundancy, if a memory bank fails, like you have multiple memory banks, if one bank fails, it exists back there. You can change the memory bank and reload from that. If a disk fails, there's mirrored disks inside, and this is every appliance. Then if you have a QA system equal to your production, you can also restore from the production into the QA. But also disaster recovery. High availability implies another system sitting on the side, ready to take over at a minute's notice. And most of that feature will come in the Service Pack 5.
Thank you for a great question. Anybody else would like to ask a question while we have this opportunity here? Don't hold back. These guys will answer anything. All right.
Oh, God.
You talked about what HANA is and what it's not. When should people consider moving to HANA, and when should they avoid moving to HANA?
Avoiding?
Or postpone it?
Come on, you're a consultant, Thad. The answer is it depends. All right, let's be more optimistic. The answer is you have options. There you go. All right, when to avoid it? I haven't come across an absolute, this is a really bad idea, don't do it circumstance. When do you want to consider this? When you're looking at a couple of ways that we boil this down, you want to do something faster. So my BW system is clogging down, and it's clogging down for what reasons? There's too much data, there's too many calculations. I'm trying to do a single follow the sun data loading cycle for an enterprise global system, and we've all done these before. This is time to start looking at where can you change your thinking on this. So by doing this, by putting this in, it's an option to not just make the database run faster, but to completely flatten down and restructure the entire data model. So your data loading becomes that much faster, everything becomes exponentially faster. That is one option, or when to at least start considering the idea. Another time to start considering the idea is when you have a problem that requires brute force computing power that you cannot address today with your current infrastructure, or it is just too manually intensive today. Too many people are spending too much time churning together too many data sets, too many Excel spreadsheets, too many Access databases, and you're looking at how do I address this? I know we've seen circumstances where these things come down from some ridiculous numbers, and in all factuality, of something that would take compiling time of days is now executing, running, compiling in minutes, because you can automate all this. Things that we never ever would have thought possible or done. I mean, I know how long you've been doing BI, BW, things we never would have advised clients to do. You look at them now as different possibilities. As far as flat out not doing it, I've seen some potentially bad use cases from an economic perspective, but not a just flat out, it's a bad idea, don't do it.
I agree.
I don't know.
Disk is dead, just effective. This is COBOL 1990. COBOL is dead, it just doesn't know it yet. Disk is dead. If you have spinning magnetic drives, it doesn't make any sense. It's the slowest possible computer media you can find. Mechanical reader arms moving back and forth. It's legacy stuff. It is like, if somebody asks you on a hard drive, why would you do a hard drive when you could do punch tape or punch cards? You would laugh at them. The reality is, in 3 to 5 years, you cannot buy hard drives. It simply doesn't, except for persistent and backup and nearline storage. To actually not compute out of memory, the value proposition is just simply not there. We will replace every single hard drive from a real-time data warehousing analytics and transaction processing in the next 3 to 5 years. I think hard drives might hang around a little longer for legacy computers, and they'll still hang around a little longer for people in nearline storage. But hard drives are dead. Magnetic drives are dead. It just doesn't know it yet. How's that for kind of brutal?
Those were great answers. All right, we'll take one more question. Gentleman in the back. Thank you.
That'll be you.
Does this also mean that mainframes would be dead as far as SAP? Once you have the HANA box sitting over there and you have this massive data out there, why would you need something as large as a mainframe to be?
I didn't hear you said mainframe.
So the question is,
dead?
I think I heard your question. Does this mean that mainframes are dead once you have this computing power in there? What is the point, or is there any point to these massive mainframes anymore? Again, I'm not the hardware side of the house. I'm going to defer that a little bit to you, and I've got umpteen zillion IBM colleagues who'd be happy to address that one for you. But I'm not the hardware side of the house, so...
Don't know.
Yeah.
In my office right now, I'm a professor too. I got a couple of PhDs in computer science, and in my office, I got a cluster computer, 8 machines hooked together as one. They're hooked together on a Western loop at 14 universities in a grid computer. I can do spectacular things. I can submit jobs right now to about 122, 123 machines instantly. And you know what? My HANA system that cost 20%, 10% of what that system cost, kicks butt. So the question becomes, we have had this problem. We have tried clustered computers, we tried grid computings, we tried massive parallel computings. We have tried every single thing under the sun in computer science. I don't think the solution goes away overnight. I don't think Cray should be nervous overnight. But the reality is, it's a paradigm shift. It's a giant paradigm shift, and it's beyond BW and ECC. Exadata from Oracle, I'm not supposed to talk about it, but they're doing the same thing. Everybody and the grandma, you did not boot up your microwave this morning. You didn't boot up your TV. You didn't boot up your Apple. You didn't boot up a Samsung. It's all in memory. This is just a logical next progression. So punch tapes and punch cards are going to hang around for a long time. We've gone through this. Every 10, 20 years we go through the cycle. We went from mechanical computing to radio tube to transistors to microprocessor. This is just a normal progression. The reality is that magnetic drives increased since 1990 is 140 times faster. Your network is now 1,000 times faster. Your microprocessors are operating 10 cores in the HANA system, are operating 500 times faster. Everything is moving faster. Memory is 2 to the 48th times bigger. And at the bottom, what's holding us back is a file system, a relational database, and magnetic drives. And the only way, we need to stop trying to performance tune junk. We just need to get rid of it and do something else. So it's going to be in-memory processing going forward. And the story is much bigger than HANA.